is so much code. Okay, I just have to lock in and cook. I need to finish this game. Okay.
That basically summarizes my experience making a mind-twisting puzzle game in 7 days as a complete beginner to Unity and C#. What could go wrong, right? Okay, so myself and a friend decided to get into game dev, but we wanted to put a hard limit on how much time we could work on the game, so there'd be no scope creep like some of our other projects we just never got finished. But we may have taken it too far. We gave ourselves 7 days to learn Unity and C# from scratch, to create what we thought would be an easy, fun, little innocent puzzle game. It was not easy, it was not fun, but I digress. The idea is you need to flip the blocks to get all green faces showing to complete the puzzle in the least amount of moves. As you progress through the levels, they get progressively harder, more blocks are added, pretty standard stuff, but this is when we hit our first roadblock. To put it bluntly, neither myself nor my mate are experts at creating puzzles, let alone generating 100 levels then finding the optimal amount of moves for each level, so that approach wasn't exactly going to fit into our 7-day time frame. But we had a plan. Essentially what we were going to do was generate an algorithm which takes 2 parameters, the types of blocks in the puzzle and the minimum moves it should take to solve the puzzle, which dictates the difficulty. The algorithm randomly places the blocks on the grid, then simulates all possible moves until a solution is found that fits within the minimum moves provided. The solution steps are then recorded and a puzzle is generated. Look at that, we can just brute force level generation. I mean, it's not ideal for boring things like time complexity, but we don't care too much about optimization. It creates unique levels, so it does the trick, or so we thought. Unbeknownst to us, we forgot to consider one very small, teensy little detail. Okay, for whatever reason, when coding the algorithm, I had a lapse in judgment and forgot that rectangles move differently to cubes, like very differently. So after a little bit of this and that, we have a working algorithm which simulated the game perfectly. So it was time to get our hands dirty and delve into Unity. How difficult could it be? Very difficult. That is the answer. Okay, so after spending like 15 hours watching Bracky's tutorials on how to set up the camera to face a cube, I was feeling pretty good about the progress for the day. Anyone that knows me knows I have a bad habit of spending time making things look nice before actually implementing the functionality. That definitely didn't happen this time. Anyway, we were able to implement basic movement controls for the cubes, but there was a little issue, and without fixing it, our game was unplayable. Let me explain. We discovered that if a rectangle is upright, you won't be able to access any cubes behind it. So what's the logical solution to this? Well, after some of this, we implemented a horizontal swipe, which lets the pillar snap rotate 90 degrees so any hidden pieces are viewable. Then we ran into our next issue. Tell me what's wrong with this. Yes, you're correct. You can't tell which pieces are cubes and which are rectangles when they're touching, which is pretty bad considering you're meant to do the puzzle in the least amount of moves, and wasting a turn flipping a piece to see what it is just seems like poor game design. Okay, but just make the cube smaller then, problem solved, right? Not exactly. You see, the way we coded the block movement is to be in scale with the size of the Unity world. To keep the numbers clean, a block face is 1 by 1 wide, and a floor square is 1 by 1, so you just need to transform the block 1 unit to get the movement to be nice. If we just downscale the cube, the floor would still be 1 by 1, so moving it from the center of one floor tile to the next would be really messy and confusing. So the totally not over-engineered solution we came up with was using this thing called a block wrapper. This is the basic idea. You create a smaller copy of the cube inside the cube, then remove all the movement scripts and hitboxes from the smaller cube, and remove all the rendering components from the bigger cube so now it's transparent. This way you can only see the inner cube, but all the position changes and swipe detections are configured to the bigger cube. But this left us with yet another problem. We now have a floating cube on our board, but luckily this was a relatively easy fix. We just had to raise the platform up to be in line with the small cube. This works because there'll always be a constant gap underneath the cube, as the smaller cube is equidistant from any edge of the larger cube despite the rotation. And just like that, nice and simply put, we had some lovely looking block movements on our game field. Definitely didn't take us hours of sleepless nights to figure out. It was time to actually put the levels we generated into the game. But how do we convert some C# code into being actual blocks in our game? Well, I'm glad you asked. Imagine you have a 3x3 grid like this, and each grid has these coordinates. Now, assuming a cube takes up 1 grid tile and a rectangle takes up 2 grid tiles, we can actually allocate the game objects to these spaces by creating a custom rectangle and cube object. So if you look here, Our rectangle object takes an array with 4 numbers. The first 2 represent the first grid space it will occupy, and the second set represents the second grid space. Same for a cube, except it only takes up 1 grid spot. So, by instantiating different cube and rectangle objects in each level data object, we're able to create levels, which can then just be called when we press on a level select button. That was kinda technical, so hopefully you didn't fall asleep, but let me show you some UI I made. For every level, there's a target amount of moves you complete the level in, and then the amount of moves you actually do. The idea is to always match the target amount, so you can win a medal. This is shown through the level select screen, where gold is for perfect moves, light blue is you just finished it, and white is the next playable level. It's sort of starting to look and feel like a game now, but now comes the next big question. So how do we make money off this endeavor? The TLDR is, we don't. We originally were thinking about being cheeky and adding in ads every level, then giving you an energy meter which runs out after a couple attempts at a level, but those money stealing mechanics in games always annoyed me when I played them and made me delete the app, so why would I include them in my own game? We basically decided that we should copy a business model similar to the game Flow Free, where you get a bunch of free levels to play through, and if you want to play more levels, you can pay $2 for some extra packs. But the real question was, is our game even fun? Yes, it is fun, but damn is it difficult. I feel kind of ashamed that I can't even beat the hardest level in the game without looking at the solutions, but I'm sure there'll be someone out there who can bang it out pretty easily. But for our first game we ever made in a time span of 7 days, I'm pretty proud of what we were able to make. Sure, there are still some bugs here and there, and the balancing of the levels isn't perfect, but it's a working game that I can get lost in for an hour or two. If you want to download games we make in the future, or just chat with me and others in our community, join our Discord link in the description, and follow if you want to see me build more games. Spoiler alert, a game jam is coming up that we're going to participate in, so keep your eyes peeled for my next video.